Hey everyone, this is Michael from Team 4411S, and this is the second episode of our Prof tutorial series. So just to give you a quick recap, in our last episode, or the first one, we set up the basic structure of our program as well as went through our globals header file and our globals source file, which you can see here. Okay, so today we're just going to be covering something pretty simple, which is just figuring out how you're going to structure your driver control code so you can just be able to drive your robot. We are probably going to fix this stuff up in future episodes and make it nicer and use some loops and stuff to control some other mechanisms. But this is going to be super simple voltage control for all of your mechanisms. So if you remember, there was a bunch of code here in our OP control function that we deleted at the beginning of the program, when we first made the program, because we're not going to be using it. But this is the function that your robot runs whenever driver control starts. So I think it's pretty self-explanatory when I say that there has to be a while loop in here, because if there isn't a loop that keeps running, then it's only going to run the code that you put in here once, and then it's going to stop. So you want this to be running at all times. Another thing you want to do is delay in the beginning of this loop or at the end of this loop by 10 milliseconds. The number that you put here in the parameter is the number of milliseconds to delay. And the reason you do this is because the motors themselves, I believe, update their values, like their motor values, their voltages every 10 milliseconds. So if you don't have this here, every time you run the loop, which is every couple milliseconds, it's going to be sending a value. It's going to be updating the value of the motors, so whatever speed you're setting them to. But half those times at least are going to be useless because you're not delaying. Because let's say for whatever, let's just give an arbitrary number, it updates every 5 milliseconds. Well, on that 5 millisecond mark, it's not going to update, but on the 10 millisecond mark, it will. Then on the 15, it won't, and on the 20, it will. So half the time you're running this, it's going to be useless. So you want to have this delay so that you can only hit the motors on the marks where they're going to be updating. And so this delay also lets pros run any other tasks that it might need to do. Okay, so hopefully that wasn't too complicated, and I just realized I said pros again. I'll try my best to say pros from now on. Okay, so let's talk about how we want to structure this code. So obviously we have our different mechanisms. So we're going to want some code to control the drive. Let's not do that motor name. We're going to want some code to control the intake. We're going to want some code to control the lift. We're going to want something to control the angling. Now, what most people do is they just hard code like, oh, let's set our motors to a certain value. But there's a much better way to do this that's still pretty basic to understand, and that's using dedicated functions inside of these files. So the reason we made these files is so you can organize functions that are specific to those mechanisms. So for example, something that would drive forward would go in the drive file. Something that would lift the lift would go in the lift file. And the function that would, make your stack straight would go in the angler file. So we want the stuff that sets those motors to be in these files, not inside of this loop. So let's go into our drive function, or drive files, and we're going to make those functions. So remember that this is for our function headers, whereas this file is for the actual source code where you actually write out the functions. So let's make a section here called driver control functions. And then the first one, let's call it set drive motors. So really basic. And so that's just what it's called, and you don't have to, it's not going to take any parameters, and you're not writing the text in this file. Okay, so now in here, we're going to actually define it. So driver control functions, can't type still. Okay, set drive motors. Okay, so all you really need to do is set the value of all the drive motors to a certain number. Now you actually want to use something. Well, let's write this out first so I can show you what I'm talking about. So we have our 4 drive motors, drive left to back. Let's just set them to 0 for now. Let's do that. So we're setting all of our drive motors to 0. But you're going to be setting the value of your drive motors a lot in all the different functions we're going to be making. So unless you want to hard code this every single time, because this isn't going to be 0, this is going to be dependent on your controller. So you're going to have to write out a lot of lines of code every single time you want to set your drive motors, unless you make a helper function. And what I mean by that is, let's make a section called helper functions. Now, obviously, helper is a beginner term, I guess, but let's make a function called set drive. Very simple. It's going to take two parameters, two integers, in left and int right. So obviously, this is going to be what it sets the left side, and this is going to be what it sets the right side. So let's do this and set this to left and these motors to right. So now that you have this function made, if you ever want to use it, all you have to do is set the drive. So we were setting them to 0, so you go like this. So it would pass these two parameters in here, so it would set drive left back and drive left front to 0, because that's what's in that slot for left, and it would set the two right side motors to 0, because that's what's in that right slot right here. Okay, so don't forget that you also want to declare the function header. So let's make our, you don't have to comment this stuff, but I mean, I'm just doing it for organization. So make sure you do that, and then make sure to put your parameters. Okay, so now for the actual driver control function. So what you want to do is take your controller input and then set your drive to that number. So a really basic way of doing this is, let's create an integer called, let's just call it, I don't know, left joystick, because you're going to be reading from the left joystick. And what you do is, remember that in your globals file, your controller's name was, well, controller. I mean, you can name it whatever you want, but we decided to name it controller. So the way that you access values from it is you type controller dot get, I believe it's get analog. So the joysticks will be get analog, but if you want to get specific buttons, it'll be get digital. So you will be going to get analog, and the parameter that you put in here is which joystick you want to be using. So controller, so let's go down this list until we see it. Analog left Y, because if you think about it, your joysticks have two axes. They have the horizontal axis, which is your left, and they have your vertical axis, which is your right. So your left joystick, you want to be looking for the left Y axis. And then for the right, you want to be, you want to be looking at the right Y axis. And the reason, and you can pretty much just directly plug this in to your motors, because these joysticks go straight from negative to positive 127. And for those of you who are used to setting motors to a certain speed or velocity because of VCS, I would highly suggest not going about it that way, because Vex's velocity control limits you a lot. This was especially apparent last year when you wanted to be doing flywheels, but it's just better to use voltage control. You'll understand why once we get more into like loops and stuff, like control loops like PID and all that stuff. So the voltage that you can set a motor to can range from positive to negative 127. And these joysticks can also range from positive to negative 127. So if we wanted to, we could just say, set the drive to left joystick, right joystick. Or you could just, put this in for left joystick and put this in for right joystick. But I just wanted to make it a little easier to understand. Of course, there's a few optimizations we can make to this. Something you might have known if you use the Cortex system is that, let's say you're not touching your joysticks at all. You'd think that the values of this would be 0 because you're not touching it. But since those sticks don't sit perfectly at 0, it might be at like -1 or 1 or 5. So you're going to be constantly setting these motors to you're going to be constantly setting these motors to like 1 or 5 or something like that, which is kind of bad, because obviously you're not touching the joystick, you don't want it to move, but you're still setting voltage because of the error from the controller. So something we want to do is set, it's called a dead zone basically. So let's pick an arbitrary number. I use 10. So let's say that if the value of our joystick is less than 10, then we don't want it to set the drive. We want it to set it to 0. Because if it's less than 10, you're probably not touching a joystick. You can make this 5, you can make this 15, depending on how much error your controller has, but we'll just use 10 for now. Okay, so let's hard code a few things. This could be very much simplified, but we're going to hard code it. So let's do if left joystick is greater than 10. Now, something you do want to do, by the way, is check the absolute value of it. Because if we're just checking if it's greater than 10, well, if it's like -1, it'll still think, it'll still think that like it doesn't work for negative numbers, basically. So if the absolute value of the joystick is greater than 10, actually, you want to check if it is less than 10. My bad. Because if it's less than 10, then you want to make it 0. So that you don't set the value of the motors to anything. You don't make them move. So if it's less than 10, you want to set it to 0. You could make brackets and then just say left joystick equals 0, but in programming, general programming, if you're only doing one line inside of the if statement, you can take out the brackets and it just only runs the line below it. So we can also say if the absolute value of the right joystick is less than 10, then we set the right joystick to 0. And then now that you've either set it to this value or you've manually changed it to 0 if it's within that dead zone, now you can actually just say set the drive to that value. And that is essentially what that function will do. So now that we've created this function, we can actually implement it in our driver control code. So all you have to do is just call the function. So set drive motors. So now every time this loop runs, so every 10 milliseconds, it'll run this function, which will set the value of your drive motors. Okay, so with this general structure in mind, we can do this same function for all of our mechanisms. So we could do set lift motor, we could do set intake motors, etc. So let's do intake next. So we're done with drive. Let's close that out. Let's open intake. Okay, so remember we're going to have our helper function. So it's going to be set intake left. You do have two sides here, so you do want a left and a right. And then you want our driver control functions void set intake motors. Okay, and this one is not going to take any parameters because it's going to read the joystick. It's going to read the controller. Okay, so let's copy this over into our intake file, and then we're going to define these. Okay, so all you really need to do for this is, well, I believe our intake motors were called intake left and intake right. So we just say intake left equals left and intake right equals right. Pretty simple. Okay, and then for our actual intake function, let's do left buttons. Okay, so we need to figure out a controller layout right now. So let's set them to 0 for now until we can figure that out. Let's make these integers. Forgot about that. Okay, so let's assume for now that our intake buttons are going to be our left side triggers. So you have two buttons on your left side triggers. You have the upper one and the lower one. So let's set, how are we going to do this? Okay, let's think about this. You actually don't want to do it this way because you're going to be setting both sides to the same number, just like an opposite number. So actually, the way you want to go about this is you actually just want one number. So in power, let's do power. Because all you're going to be doing is you are, even though you do have two sides, they're always going to have the same power. There's no reason to set them to a different number. You'd think that the right side would be like negative because it's spinning the opposite direction, but we took care of that in our globals file because if you'll notice, the intake left motor was set to false, being reversed, and the right motor was set to true being reversed. So when it's set to true, any number you set it to will automatically become negative. So we can just set them both to power and it'll automatically take care of that stuff for us. Okay, so, but what we do need to figure out here is our number. So intake power. So let's call it intake power, and we need to figure out what number to set our intake motors to based on the value of those two buttons. So we could make this really long statement and be like, if the value of the, so I'll write it out for you. If controller.get digital, I believe it's, so let's scroll down. Digital, I believe left 2 is the top one and left 1 is the bottom one. So let's say that, let's write this out here. So bottom button or bottom trigger intakes, top trigger outtakes. So let's type this out. So we want it to, if this button is pressed, the top one, then we want it to outtake. So if it's pressed, set intake power to negative 127, because you want it to be going full speed outwards. And then else if controller.get digital, let's scroll until we find it. I believe it's L1. So you could write it out like this, and then just, well, set the intake to intake power. So, but this is like kind of an inefficient way to do it, because you have to run 2 if statements, which takes, I mean, it's like not that much more strain, but like there's just better ways to write it. And what you have to realize is this function here returns a Boolean. So if the button is pressed, it'll return true, which is why this if statement will run, and it'll set the intake power to negative 127. But something you also have to consider is that in programming, the Boolean true is also equal to the integer 1, and the Boolean false is also equal to the number 0, which might be a really weird concept. But you can actually use these Booleans as integers, and we can take full advantage of this in just a quick second. So let's get rid of this, and what you can do is something like this. So we're going to scale it by 127. You'll understand what that means in a second. And then we're going to do controller.get digital. I shouldn't have deleted all that because I could have copied it. But we're going to do L1 minus this with L2. Okay. I might actually be wrong in that it might be that the bottom trigger is 1 and the top trigger, that the bottom trigger is L2 and the top trigger is L1, and if I am, then just switch these two, but that's okay. So what we're effectively doing here is, let's run through some scenarios. So let's say you're pressing L1, which is the bottom trigger, hopefully. So this part's going to be 1 because you're pressing it, and this part is going to be 0 because you're not pressing it. So what you're effectively getting is 127 times 1 minus 0. So it's going to be 127 times 1. So it's going to set your intake to full speed 127. If you're not pressing L1, but you're actually pressing L2, then it's going to be 0 minus 1. So you're setting it to 127 times negative 1. So you're setting it to negative 127. If you're not pressing either, then it'll be 0 minus 0. So you're setting it to 0. And if you're pressing both, it'll be 1 minus 1, which is also 0. So this takes care of every possible situation that you could have been in for pressing those buttons, all in one line. So there are ways to make code more efficient, and I thought this would be understandable enough to include in this part of the program. But if you don't understand this part, then feel free to just do it the hard-code way before. Okay, so with this concept in mind, we can do all of our other functions, because all of our other functions for our lift and for our angler are going to be using buttons. So the digital stuff, not the analog stuff from our drive. So we can pretty much copy paste these functions for the rest of our stuff. But really quickly, we're going to do set intake motors here in our OP control function. So now that we have stuff for our drive and our intake. So we just need to do our lift and our angler. So real quick, I'm just going to, let's see. I'm just going to copy this stuff over to our lift first. Let's do that. Okay, except we're going to change this, obviously. Set lift, and this is only going to set one motor. Sorry if I'm going too fast, but we're basically just, we can apply the same structure because we have our helper function to set the lift motor, and we have our set lift motor function here. So instead of intake power, it'll be lift power, and obviously we'll set this to lift power. And let's say that we want our lift function, or our lift buttons to be our right side triggers. So we just change this from L1 and L2 to R1 and R2. Now something you do want to change is the order of these, because you want to lift upwards if you're pressing the top trigger, which is R2, so you want this to be the positive one. And you want to go downwards with the lift if you're pressing the bottom trigger, which is R1. So you want this to be on the negative side. And then obviously you got to do set lift as well. Okay, so now, oh wait, I pasted this into our header file, but I should be pasting this into our source file. My bad. Now obviously you just take this out and then just put that. Okay, so we have our function definitions in our header file, and our actual function text in our source file. And then real quick, we can literally do the exact same thing for our angler, but let's just do this, set lift motor. Okay, now let's just really quickly put this into our angler files. Okay, so let me be careful and put this in our source file now. So we're going to do set angler, and then set angler motor. Hope this isn't too incredibly tedious, sorry. Typed that wrong. And then set angler. Okay, now we need to figure out what buttons we're going to use for this. I'm going to assume that since you're using the two sets of triggers, for your lift and your intake, that you're going to be using the actual buttons on the surface of the controller for the angler. Now there's obviously some more advanced controller setups you can use so that you only need to use the triggers, which is preferable for someone like me who uses tank drive, so you don't want to have to be pressing the buttons on top. But that's some more advanced stuff that we can get into later. Like in Turning Point, we did, if you like double tap certain buttons, it did different functions, but that will require a little bit more advanced programming. So let's assume that our button to put the angler outwards is, I don't know, let's make it A, and then our button to, well, actually, let me Google something real quick. Let's Google Vex V5 controller. Let's figure out what we want to do with this. Okay, so let's do, so this is outwards and this is inwards, so up and down, pretty simple. So digital up and digital down. So obviously upwards would be our positive one to make it go outwards and more vertical, whereas downwards would make the angler go back into the robot. Okay, and this is of course assuming that in your globals file you have the direction of the motor set properly for your lift and your angler. If not, you can change that in your code, obviously. But okay, so all you really need to do now is just set angler motor in here. And gotta make sure that we did our stuff here. Let's just do our function definitions. Because okay, so if you'll notice, we have an error here. It says undeclared identifier. So it means that it's not recognizing the name of the function. And the reason it's not recognizing it is because in our header file we don't have that in there just yet. So we have to name it set angler before you can read it in our other files. Hopefully that makes sense. Okay. We don't need to worry about this text because we already took care of that. Okay, so everything's pretty much taken care of now. I'll edit this comment out because obviously that wasn't needed for the other subsystems. But see, now it reads the function. Okay, few last things before I wrap up this episode. Let's say for our angler, for example, that you wanted to use a potentiometer for whatever reason. instead of, so let's say for autonomous, when you want to make the stack vertical, let's say you don't want to use the IMEs in the motor to calculate the rotations that you need. You want to use a potentiometer. I would probably do that just because I like the wider range that it gives you. So what you'd want to do is, let's see, we're not using this just yet, but you'd want to declare your potentiometer here. So ADI potentiometer, somewhere around here. Okay, so ADI is like the old stuff that pros had, or not pros, the old stuff that you'd use with the Cortex. For example, if we go back to the pros API, they have all of this ADI stuff. So this would be all of the stuff with the 3 wires that worked with the Cortex. So like all those motors, the quadrature encoders, an ultrasonic sensor, gyroscope, potentiometer, line tracker, all that stuff. So let's call it, I don't know, angular potentiometer, angular pod. And then the parameter you put in here is the port. So let's say, I believe they're lettered from A to G. So let's assume it's in port A. So all you gotta do is type in that character A, put it in asterisk because it's a character, and then that's your potentiometer. So if you want to use it later on, now you can reference it and you can get the value from it. But we're not going to be doing this until a little later. But I think that wraps up most of it. So just a quick recap. We've created everything we would need for a driver control. So now you can drive your robot around. From now on, it'll just be like pretty much autonomous programming and a little optimizations here and there. So we've created our drive functions so that we set all of our motors and take our controller input, process it for that dead zone, which I apparently did not save. My bad. And then set the joystick values. But that's fine because you're probably going to be doing it this way anyway. Okay. And then we've also taken our angler, our lift, and our intake code and structured it the same way as the drive so that you have the function that you call in driver control and you have your helper function, which you will also be using a lot in autonomous for every single mechanism. Okay, I think that wraps up this episode. Hopefully this helped, and stay tuned for more. Thanks. Bye.